All right, so here's the end of that test prep. Question number 63 on. It says, solve this equation. That means find the zeros. It says, first list all the potential. That almost says the word potential. It says potential, but that should really say potential. That would be IAL is what it is. All right, so the list are all the numbers that go into 24. Then we test the list using synthetic division. So, because I know the answer, I know which numbers work. You don't. You'd have to keep trying until something works. 1 doesn't work, but you'd have to keep trying until you find the one that works. So, a positive number that works is 3. And then what you're left with is x squared plus 6x plus 8. Factor. And you have your answer. So what are the solutions here? Or the zeros. So 3 is an answer. Each factor has a solution. So -2 and -4. And those are your solutions. Next, again, potential, rational zero. So focus in 8. So all the numbers that go into 8 evenly. And then we use synthetic division to see which ones work. This one, again, does not add up to 0. So you'd have to try until you find it. The one that works is -4, because I know the answer. If I didn't know the answer, I'd have to keep trying until 1 gives me a remainder of 0. What's left over is x squared minus 2x plus 2. I'm just going to, even though it says find the answers that are real, I think this is good practice. To solve this, it's not factorable. It is a good candidate to complete the square. And the reason is because it's a simple trinomial and b is a even number. I'm going to subtract 2. On the side, or above here, I'm going to take b, which is -2. I'm going to divide by 2 and square it. So that gives me the answer 1. So I'm going to add 1 to both sides. The left now is factorable, and it's the same number, -1, -1. So we square it. On the right is -2 plus 1, which is -1. At this point, I know there's no more real answers. So I'm going to take the square root to both sides. I know that when solving a quadratic, the answer is positive or negative. I know the square root of a negative number is imaginary, and the square root of 1 is 1, but I don't need it there. The last step to get x by itself is to add 1 to the other side. So the positive 1 and the positive and negative I are unlike, so they just go beside each other. So what are the solutions here? -4 was an answer, and we have 1 plus and subtracting I. And those are the solutions. Number 65. Again, we're going to list it. So 24. We just did 24. I'm going to test using synthetic division. And again, I know the answers, so that makes it obviously much easier for me. So which one would work here? Oh, do you notice all the numbers are positive? That means no positive zeros would give you 0. And if you think about it number sense-wise, there's no way a positive number could give you a 0 at the end. You need some positive and negatives to be able to give you the answer 0. So they're all negative. So -2 is a 0. What you're left with is x squared plus 7x plus 12. I'm going to make that equal to 0 and factor it. Two numbers that multiply to 12 and add to 7 are 3 and 4, and those are my solutions. So -2 is a solution, and each factor is a solution. So -2, -3, and -4. All right, number 66. Again, list, so the last number, the constant, all the numbers that go into 10. 1 is in front, so that stays the same. Do synthetic division. of 1, 3, negative 8, and 10. Again, see what numbers may or may not work here. I know the answer because I know the answer, but you would have to keep trying until you found one that gave you a remainder of 0. So it's negative 5. And again, in fact, I'm left with exactly the same answer as before. So 1, negative 2, and 2. So do you see how we did this one already before up here? So I'm not going to go through all the same work again. So we're left with the exact same quadratic. So I know the answer because I already did the work. 1 plus or minus I. So our solutions then, we found negative 5 and then 2 complex. 1 plus and 1 subtract I. All right, turn the page. So for 67, can you find the missing 0 by using the conjugate pair theorem? So 1, 4, subtract I. I need to remember that complex numbers come in pairs. So 4 subtract I, the other, one that's missing is 4 plus I. Again, the one that's missing here, I have I, so that means negative I must be a part of it. 1 plus I, so 1 subtract I. So I was missing 2 of them because complex and imaginary zeros come in pairs. So I have 7 subtract 5i, so that's 7 plus 5i, and then 9i would give you negative 9i. So those are the 2 that we're missing, as they always come in pairs. Number 70, use the given 0 to find the remaining zeros of the function. So I know negative 3 plus 2i, that means negative 3 minus 2i. What I'm going to do is, I'm going to multiply those 2 together. There may not be enough room here to do the work I want to do. So I'm going to multiply it together, and then I'm going to divide into here, and I'm going to have to use long division. So I might go to another piece of paper. So I'm sorry. So negative 3 times negative 3 is 9. Negative 2 times negative 2 is 4. But I squared, wait a second, negative 3 plus 2i, negative 3 minus, there we go, okay. So positive 2 times negative 2 is negative 4, but the I squared is negative 1, so it makes it plus 4i. So be aware that I squared equals negative 1. So when I have negative 4i squared, the negative 1 makes it a plus 4i. All right, I'm going to do this on another piece of paper, sorry. So I'm going to, oh, what did I do wrong? Let's try it again on a totally different piece of paper. So, I'm going to multiply these 2 together. So I'm going to do the factors. That's what I didn't do. The factors. So subtract 3, negative 3, plus 2i, and subtract negative 3 minus 2i. I'm going to distribute, so I have plus 3 and minus 2i, plus 3 and plus 2i, and then I'm going to multiply this out. So I have x plus 3 minus 2i, x plus 3 minus 2i, and I'm going to multiply it out. Some things are going to cross out, thank goodness. Oh, this is negative 2ix. I don't know what I was doing. Here is negative 6i. Here is, what am I doing? This is a plus. So this is plus 2i. I knew things have to cross out. So if they're not crossing out, then I'm doing something wrong. Plus and plus is plus 6i. This is negative 2ix. See, these have to cross out. That's why I knew something was wrong. On negative 6i and positive 6i cross out. And then I got negative 4, but the I squared makes it a positive 4. So what I get here is x squared plus, how's that 9? 3x. I'm not having a math day here. So x times 3, that's 3x and 3x, which is 6x, and then 9 and 4, which is 13. I think I'm here. So I'm going to take that answer and divide it into the function. So I take that answer. In the question it says x cubed plus 7x squared plus 19x plus 13. I have to do long division. So x cubed divided by x squared is x. Subtract, I get 1x squared, 6x, and 13. Well, x squared divided by x squared is 1, and they actually, and this is because they're factors, and it better be that the remainder is 0. So the question is, use the given 0 to find the remaining zeros of the function. So if the factor is x plus 1, then the 0 that's left is negative 1. So we have negative 1, and the other was negative 3 minus 2i. Let's try that again. I'm going to do it right from the beginning. So I need to do it on a separate piece of paper. So 71, you have 2 plus 3i. That means you also have 2 subtract 3i. So I'm going to write these as factors. So x subtract 2 plus 3i, x subtract 2 subtract 3i. I'm going to distribute. I'm going to multiply it out, 3 by 3. I really think the algebra is really good for you to practice, so I don't mind doing this at all. I know that learning a new skill and practicing it is not always easy or fun. So x squared minus 2x minus 3ix, negative 2x 4, 6i, 3ix, negative 6i, and 3 times negative 3 is negative 9i squared, which makes it a positive 9. So all the ugliness eliminates. And what I'm left with is x squared minus 4x plus 13 again. So again, I'm going to divide. And then in the question, it gives you this function. X cubed divided by x squared is x. When I subtract a negative, it's positive, and 5 6 is negative 8x. 2x squared divided by x squared is 2. No remainder. So I now have my answer. So this is the factor I didn't know. So from this factor, the 0 is negative 2. And then we got negative 3 minus 2i. Or 2 minus 3i, I mean. So negative 2, we had to work at that one. 2 subtract 3i is the conjugate pair theorem. You'd know that right away. All right. A couple more left. List the potential zeros, 1, 2, and 4. Test using synthetic division. So it's not that long the list, thankfully. 1, negative 1, 4, and negative 4. Well, positive 1 works, thank goodness. And what I'm left with is x squared plus 4. So if I solve that, subtract 4 and take the square root. So this, when you solve a quadratic, the answer is positive or negative. The square root of a negative number is imaginary. And square root of 4 is 2. So what are all the zeros? It's 1 and plus and minus 2i. Done. List the zeros, plus or minus 1, 2, 5, and 10. Divide using synthetic division, 1, 5, 4, and negative 10. We're not as lucky in this case. So positive 1 is not going to work. I'm going to get the answer right now, and then, so I don't have to show you all the wrong answers. So 5x squared plus 4x minus 10. All right. Why did I say positive 1 didn't work? It does add up to 0. Positive 1 works. All right. No remainder. What I'm left with is x squared plus 6x plus 10. A great candidate to complete the squares. That's what I'm going to do. So I'm going to subtract 10. On the side, I'm going to take 6 divided by 2 and square it. So 6 divided by 2 is 3, and 3 squared is 9. So on the left, I have what two numbers multiply to 9 and add to 6 are 3 and 3. On the right, negative 10 plus 9 is negative 1. When you square root both sides to solve a quadratic, the answer is positive or negative. The square root of a negative number is imaginary, and the square root of 1 is 1. Now, we have one more step here. We need to subtract 3, so it's negative 3 plus or minus I. So positive 1 works, and it's negative 3 plus or minus I. All right, let's do it again, and we're almost done. So list the potential zeros. We're going to test using synthetic. So I recognize there are no positive numbers that are going to work because they're all positive numbers. I'm going to make sure I know the zero that's going to work. I think it might be negative 1, but we're going to make sure. So it is negative 1. I have x squared plus 6x plus 14. So to solve this, I'm going to complete the square. So I'm going to subtract 14. Then I just did this work. So I'm going to take 6. I'm going to divide it by 2, square it, and so on. Remember, we just did that way up. There it is. So what's the number I'm going to add to both sides is 9. So on the left side, I have x plus 3 squared. This is negative 5. So when I solve a quadratic, so you take the square root of a negative number, it's plus or minus, it's imaginary, and then the square root of 5, well, I don't know it. So we just write it as the square root of 5. So the last step is to subtract 3, and then I have my zeros. So the zeros in this case, negative 1, and then negative 3 plus, and subtract root 5, I root 5. There's the I root 5. All right, last one. It says factor this one. I will factor this one. Two numbers that multiply to 100 and add to 29. So two numbers that multiply to 100. That's 25 and 4. Take each one, make it equal to 0, and then solve it. So we're going to subtract 25. When I take the square root, it's positive or negative. The square root of a negative number is imaginary, and the square root of 25 is 5. So just think through it. So it's positive or negative 2i. And there they are. All of them are imaginary. So there's the prep for your test. Mr. G Math, over and out.